So all those functions that we did in the first video or in part one of this were all in standard form. So if we go back here, notice that it was always just 1x squared, 1x squared. So for all of these, we were already in standard form. Well, what happens when we're not in standard form? When we're not in the form where we can easily find our vertex? Well, if we're given general form of a quadratic, remember that's ax squared plus bx plus c, in order to get into standard form, we need to find our vertex. Well, how do we do that? Well, again, the vertex is h and k. H is found by the formula negative b over 2a. Well, where does b and a come from? Those come from the values of the general form of a quadratic. K, the y value of the vertex, is the function's value at negative b over 2a, or you can think of it as the function's value at h. So what happens is first you find your h, and then you plug that value back into your function and solve, and that'll give you the y value. So once you do that, once you find an h and a k, you're going to plug in your h and your k and a. Again, a is going to come from that original function into the standard form formula, and then you'll have your function in standard form. Let's look at a few examples. The examples say to determine the standard form of a function as well as find the vertex and the range and graph the function. So let's go ahead and start by finding the vertex. The reason that we're going to start by finding the vertex is, again, I need the vertex to get into standard form. So it's the first thing that I need to do. Well, in order to find the vertex, which is my h and my k, I first need to identify what a, b, and c are in the general form that I'm given of my quadratic. Well, a is going to be the number in front of x squared. There's a negative there, so I say negative 1. b is the number in front of your x term, negative 4. And c is the constant, which is negative 3. All right, let's go ahead and find h. Well, again, h is equal to negative b over 2a. So plugging in, h is equal to negative, well, b is negative 4, so it's the negative of negative 4 over 2a. A is negative 1. So if we clean this up, we get that h is equal to, well, the negative of a negative is a positive 4. 2 times negative 1 is a negative 2. Well, 4 over negative 2 is negative 2. So the h of my vertex, or the x-coordinate of my vertex, is negative 2. Now I need to find k. Well, k is the function's value at whatever h is. So let's go ahead and find k. So finding k, what we need to do is we need to find f of h, and h happens to be negative 2. So what that tells us to do is everywhere there's an x in my function, instead of writing x, I'm going to write negative 2. So we have negative x squared, so negative of negative 2 squared minus 4x. Instead of x, I'm going to write my negative 2 minus 3. If I work this out, f of negative 2 is equal to the negative of 4 plus 8 minus 3. Continue to go here. Negative 4 plus 8 is a positive 4 minus 3. F of negative 2 is equal to 1. Well, remember, this is your k. So the function's value at whatever h is gives you your k. So my k is equal to 1. So now I found my vertex. Well, once you have your vertex, you can find standard form. What you need to do is you need to plug in a, h, and k. So a in this problem is your original a. So our original a is negative 1. So we're going to say negative 1 and then open our parentheses. Then x minus, well, minus h. H happens to be negative 2. Minus and minus is plus, so we'd have plus 2, quantity squared, and then plus k. Well, k was 1. So the standard form for our quadratic is f of x is equal to negative 1 times x plus 2 squared plus 1. All that's left is the range and graphing. Again, it's easiest to graph first and then find the range. Well, the vertex is negative 2, 1, so go ahead and plot your vertex, negative 2, positive 1, and then use the compression stretch to help you finish graphing. Well, the compression stretch is a, which is negative 1. So again, the compression stretch is equal to negative 1. And that means that from this point of negative 2, 1, I go down 1, 1 to the left, and down 1, 1 to the right. Those are the only 2 points that I need to finish off my parabola, and there we go. So now we need to find the range. Well, what is the range of this function? Again, range, we have to go from bottom to top. Go from the bottom. What's the first thing I get to? Arrows. So it's parentheses, negative infinity. And then the last thing I get to when I go is that top dot. Well, what is this top dot? Well, the y value of this top dot is equal to 1. So my range is from negative infinity to 1. All right, let's go ahead and look at example 5. Example 5 is same thing. We need to get this thing in standard form in order to work all this problem. Well, in order to be in standard form, I need to know my vertex. So to find our vertex, first identify A, B, and C. Well, A is going to be the number in front of x squared, so 3. B is the number in front of x, negative 12. And C is always your constant term. Let's find H, because again, start by finding the vertex. Once you know the vertex, you plug in and you find standard form. So the vertex, I need to find H first. Well, H is going to equal negative B over 2A. That's the formula. So H is equal to negative, well, B is negative 12, so the negative of a negative 12 over 2A, over 2 times, well, A happens to be 3. So let's go ahead and work this problem out and see what we get for H. Well, the negative of a negative is a positive, so we have positive 12 over 2 times 3 is 6. Well, 12 over 6 is 2. So the H value for our vertex, or the X value, right? H for our vertex is 2. Well, now we need to find K. Well, K is always going to be the function's value at H. So the function's value at H. Well, what does that mean to do? Everywhere there's an X in the original function, instead of writing X, I write 2. So we say 3 times 2 squared minus 12. Again, instead of X, I'm going to write 2 and then plus 9. So again, everywhere there was an X in my f of X, I replace it with 2. So keep going here. K would equal, well, 3 times 2 squared, or 3 times 4 minus 12 times 2 is 24 plus 9. Keep going. 3 times 4 is 12. 12 minus 24 plus 9. Well, 12 minus 24 is a negative 12. If I add 9 to that, I get negative 3. So the K, or the Y value of the vertex, is negative 3. Now that I know H and K, I can plug into standard form. So remember, standard form is f of x is equal to A times x minus h squared plus K. So let's go ahead and find standard form. F of x is equal to A. Well, what's A? A is the original A, which is 3. Then I open up those parentheses, x minus, well, minus what? Minus the x value there, which is 2, quantity squared plus K. Well, plus a negative 3 is honestly the same thing as saying minus 3. So instead of writing plus a negative 3, we just write minus 3. So the standard form for this quadratic is f of x is equal to 3 times x minus 2 squared minus 3. Well, let's go ahead and graph our parabola with that vertex and that compression stretch. Again, the compression stretch is equal to 3. So 2, negative 3. There's our vertex. Then the compression stretch says, all right, from that point, I need you to go up 1, 2, 3 units and 1 to the left. Back from that vertex, we go up 1, 2, 3 units, 1 to the right. Connect your dots, and there we go. That is the graph of 3x squared minus 12x plus 9. Again, we need the graph to find our range. So we go along. The first thing we get to is that purple dot. Well, where is that purple dot located? It's located at the y value of negative 3. So our range would be negative 3 with a bracket because there's a closed circle. The last thing I get to is arrows. Arrows means infinity, so I say comma, infinity, and I close the parentheses. All right, let's look at the last one, finding the standard form, before we get on to the next part in this section. So again, need to find standard form. In order to find standard form, I first need to find my vertex. So let's identify A, B, and C. So A is equal to 2, B is equal to negative 10, and C is equal to 8. So let's go ahead and find the H value. And H, remember, is negative B over 2A. So H would equal the negative of negative 10 over 2 times 2. So the negative of negative 10 over 2 times 2. Well, the negative of negative 10 is just a positive 10 over 4. Well, this reduces to 5 over 2. So the h value for the vertex of our parabola, or the x value, I should say, is 5 over 2. Well, what is k? Right, let's plug that in. Remember, it's the function's value at 5 halves. So we say 2 times 5 over 2 quantity squared minus 10 times 5 over 2 plus 8. And if this problem scares you just because there's fractions, go ahead and work it out on a calculator. I'm going to do it by hand here. So 5 over 2 squared becomes 25 over 4. And then here I can put my 10 over 1. If I cancel, I'm left with 1, 5 in the numerator, and 5 times 5 is 25, again plus 8. Same thing in the next one. I want to cancel. I can cancel, leave 2 in the denominator and 1 in the numerator. So k would equal 25 over 2 minus 25 plus 8. Well, 25 over 2, I may or may not know that's 12 and a half, but I can figure that out if I just perform division. So it's 12.5 or 12 and a half. I'm going to make a decimal just to make the rest of the addition and subtraction much easier. So 12.5 minus 25 is a negative 12.5. If I add 8 to that, I get negative 4.5. So the k value for my vertex is negative 4.5. Again, if this part was scary to you, just use a calculator, plug it all in a calculator, and don't worry about it. Don't get hung up on the adding and subtracting of fractions in this class. Then, the h value. Well, I didn't write in the h value yet. Well, the reason for it is, again, I'm graphing. And if I'm graphing, I might look at this and say, I don't know where 5 over 2 is. But 5 over 2 is really just 2.5. Or 2 and a half. So I'm going to make the vertex in decimal forms. So going ahead here, let's find the standard form. Again, standard form is that f of x is equal to a times x minus h squared plus k. So f of x would equal, well, what's a? A is 2 times x minus, well, what's h? H is 2.5, and I'm okay if you write 2.5 or if you write 5 over 2, whichever you feel more comfortable with, squared plus, well, plus and negative is the same as minus, so we can say minus, and again, I don't care if you write 4.5 or 4.5 is really 9 over 2, so it just depends on what you prefer. Again, I'd be fine if you had 2.5 instead of 5 over 2, and I'd be fine if you had negative 4.5 instead of a negative 9 halves. Whatever you feel most comfortable with. Well, let's graph the vertex because we need to graph the function itself so we can find the range. So I have 2 and a half, and then negative 1, 2, 3, 4 and a half. So there's the vertex of my parabola. Then the compression stretch, again, is A. So what's the compression stretch? The compression stretch is equal to 2. So that's telling me from this point I need to go up 2 units over 1 to the left. Back from that vertex I go up 2 units, 1 to the right. Connect my dots, and I have the graph of this parabola. All that's left is to find the range. Again, the range is the lowest to the highest. So if I go along here, the first thing I get to is that point. Well, what's the y value of this point? Well, the y value of that point is negative 4.5. So I'm going to put a bracket with negative 4.5. Again, it's a bracket because we have a closed circle. Then we keep going and we keep going, we get going, and we get to arrows. Well, arrows means positive infinity. So this goes all the way to positive infinity. The next video is going to deal with finding the minimum and maximum values of quadratic functions and also finding their x-intercepts.